Hello and good morning everyone. Assalamualaikum to the Muslims and a very good Wednesday to all of you. So I hope you're having a bright Wednesday. How's the weather in your place? Was it rain? Was it shiny? Oh, how is it? Okay, so before we proceed with today's lesson, first and foremost, I would like to thank you. Thank you for being here. And this is the attendance form. You may fill them up before we begin with the lesson. No need to upload any works. Okay, so yesterday we have finished discussing exercises on reflection of wave. So I hope you have a clear understanding what is reflection of wave. So we have seen through reflection of wave either for water wave, okay, focusing more on water wave, okay, especially reflection on plane wave. Okay, so students, so for today we are going to check on the Ford Content Standard 5.4, as you can see on my screen now. Before that, am I sound clear to you? Can you give some response? So please call up your friends to be here as soon as possible so we can begin with refraction of wave in a few while. Okay. So this is our lesson, refraction of wave. We'll be focusing on two types of waves, which are water wave and sound wave. Okay. So who's here? You may check. You may respond to me by typing your answer in the live chat later on. So everyone, for Akid, for Baiduri, for Citrin, are you ready to begin with the lesson? Okay. Sudah sedia ke nak mula? Boys and girls? Boleh dengar cikgu dengan jelas tak? Okay, am I sound clear to you? Okay, so this is okay, thank you Sinwei. Okay, so that's sedia. How about the rest? Are you ready and good to go? So you may prepare with the module which I have shared in your Telegram group earlier. For those who have printed, you can check them. For those who don't have any printer back home, you can get ready with your exercise book and you can jot down any important notes. Okay, so very well. So what is refraction of wave? Before we go to the definition and take a look at a few examples, what happened to the wave which undergo refraction? So first and foremost, let us take a look at this situation. Okay, I want you to observe this situation and tell me what happened to the motion of the car. Okay, what can you see there? So you may respond to me. What happened to the car? Observe the motion of the car. Okay. Share your opinion. What happened to the car as it moved from the road entering a mud road? Okay. From the asphalt road and then entering a muddy road. What happened to the motion of the car? Any changes you can see there? Or it's just the same, moving on the road and moving on the mud. Okay, anyone? Far away from Sempadan. Far away from Sempadan, Sinwei said. Angle big. Okay, angle big. Okay. Any other idea, any other opinion? What happened to the motion of the car as it travel from the road entering the mud? Okay, it's a good try, Sinwei. Nanti kita tengok. Okay, the rest of you, what do you say? What happened to the motion of the car? So here you can see that the direction of motion, the direction change, Sinwei. Okay, the direction of motion of the car changes as it moves from one medium to another. The first medium is the road. Okay, and then the second medium is the mud. So you can see that on the road, this is the initial direction and the car is moving in this direction. Okay, in a straight line. And then entering the mud, what happened to the direction? You can see that the angle of direction changes. Dia pergi macam ini. Okay, so we can say that the direction of the motion of the car changes as it moves from one medium to another. Okay. Next, what about this? So we have 3 animation there. All these are a few example of wave. The first one, what kind of wave is this? This is, yes, this is light wave. This is also light wave. Ini light wave from air traveling into medium here. Let's say this is perspex and then come up into the air again. This one also an a light wave traveling through air, entering a glass and then went back to air. Okay, and then here this is water wave traveling from the blue region, entering the green region. So what can you say about the motion of the wave here? Again, we can see that the direction of propagation, okay, direction of motion. So direction of propagation of the wave changes as they propagate from one medium to another. Okay, so one medium to another, from air entering perspex and then went back to air. A entering glass, entering A. So the medium here is A and glass. Here the medium is A and perspex. Here the medium is, if this is water, mean the medium is water at a different depth. Okay, so this one, direction of propagation of the wave changes as it propagates from one medium to another. Okay, the density of the air is lower than the glass. Okay, yes, Sinway. Okay. Okay, next. So class, these two situations will bring our understanding on what is the meaning of refraction of wave. What does refraction of wave refers to? Okay, so how can we write? Refraction of wave is the change in direction. The word that I highlight in a yellow word is the keyword. Okay, the change in direction of the propagation of the wave due to or caused by the change in the velocity of the wave as they travel or propagate from one medium to another. Okay, so again, what is refraction of wave? Change in direction of propagation of the wave due to change in velocity as they travel or propagate from one medium to another. Okay, here you can see another example. The wave is traveling from the gray medium entering a blue medium. So you can see that the direction is changing actually due to changing in velocity when it travel through two different medium. Okay. So what is this medium refers to? Medium is the environment, okay, the region. So medium can be, the two medium can be either physically different. For example, we have air and water here. Air and water are physically different. Or the medium can be different in density or different in optical density. Okay, different in density or different in optical density. For example, from air entering glass, it has two different optical density. If we are talking about sound wave, so it travel of different layer of air, mean different density of air. Okay, and the medium also can be referred to mediums of different depth. Here, if you are dealing with water wave, here is the deep region and the other side is a shallow region. So remember, medium is the environment, okay, where the refraction took place. So it can be physically different, it can be different in density or optical density, or it can be different in depth. Okay, depend on what type of wave we are dealing with. So are you clear so far, refraction of wave? Okay. If you have any question, you can type on the live chat, or you can also join my studio by clicking on this link. Okay, this is the link to enter the studio. Okay, then students, okay, next. Okay, so this is the medium. So what's next? Okay, so how does the speed of light influence? So what factor influence the speed of wave? First one here we have light wave. The speed of light wave influenced by optical density of the medium. So here we have, you can see that the pencil is bending, appear to be bent. Okay, this is a normal example of situation involve refraction of light. You can see when we place a pencil in a water, you can do it later. Take a cup of water and put your pencil inside. So you can see that the pencil will appear to be bent. Nampak bengkok pencil itu. That is actually due to changes in speed of light as it pass through from air entering water. So which speed is higher, speed in water or speed in air? Light travel in a higher speed in which medium, water or air? What do you say? In which medium light wave travel at a higher speed, in the air or water, if according to this diagram? What do you say? High speed in water or in air, students? It should be in air. Okay, light travel in a high speed when it is in a medium of air. Okay, so second, speed of water wave influenced by the depth of water. Okay, so water travel at the highest speed at deep region. Okay, and it travel at lower speed at shallow region. Later we will talk more details on that. While for sound wave, okay, speed of sound wave influenced by density of air. Okay, density of air, we have hot air and cold air. This one also later we will check on more details when we are looking at the application of refraction of sound wave. Okay, yes, in way it is air. Okay, then students, okay, so that is the introduction on refraction of wave. So again, what is refraction of wave? It is the change in direction of propagation of the wave, which is due to changing in velocity as they propagate from one medium to another. Okay, so for learning standard 1, actually there are 4 learning standard. Each and every one of you must master in this content standard for refraction of wave. The first learning standard is you have to describe the following aspects. This is the characteristic of wave: angle of incidence, angle of refraction, R. R here is angle of refraction. Kalau reflection, R ini angle of reflection. Okay, for refraction of wave, it used the same symbol, I angle of incidence, but R is now angle of refraction. And then lambda is the wavelength, frequency, V is speed, and direction of propagation. So later we will see what happened to all these characteristic of wave after once they undergo refraction. Okay. So before to answer that, we will check on this experiment 5.4 to study refraction of wave for plane wave. Plane wave here refer to water wave, okay, which we can produce using a ripple tank and its accessory. So this is our apparatus, ripple tank and its accessory. Accessory, all these are the generator, the lamp, okay, the vibrator, dipper, and so on. And then we need a digital xenon stroboscope. Remember yesterday I told you what is stroboscope used for in this experiment. It is used to freeze the wave. So we can see the pattern obviously if you need to sketch or if you need to study what happened to the wavelength, what happened to the direction of motion and so on. Okay, and plane dipper. So we are using plane dipper to produce the plane wave. So once the plane dipper is on, the ripple generator is switched on, so the plane dipper will start to vibrate. So the moment it vibrates, it will produce a plane wave. Okay. And we also need a perspex sheet. Perspex sheets is to create different depth in this ripple tank. Okay. And these are the material, marker pen, silicone tape, distill water, and so on. Okay, so the procedure you can read through. Ini you boleh baca from number 1, how we do the setup until number 10. Okay, so this is what we have to determine. Number 9, you have to find angle of incidence, angle of refraction, and also the incident wavelength and the refracted wavelength. So we repeat this experiment 5.41. First of all, this is how we place the perspex plate. Okay, so I zoom it for you. In arrangement 5.41, okay, so when we place the perspex sheet there, it will create shallow region. Mean the water on top will be shallow, and we place it in this direction. So this is the deep region. So water is traveling from this or entering shallow region. Okay. Meanwhile, for the second arrangement, the water started propagate from shallow region, entering a deep region. Okay. First it enters shallow and then propagate to a deep region. Okay, then this is the observation you are going to see if you did this experiment for figure 5.4, where the water wave travel from deep region entering shallow region. Okay, this is how the water travel in the deep region. So it enter shallow region. Okay, in as shown here in this animation. So deep region entering shallow region. So you can see clearly that the direction of propagation changes once it enters the shallow region. So this is the boundary between the deep and shallow region. Okay, students. So this red line, can you tell me what is this red line represent? The red dash line here, it represent what? Anyone? The red line here represent what? Who knows? Okay, come on, type your answer in the live chat so I can see either you're following this lesson, understanding or not. Very good, Jiayu. Yes, this is the normal line. Okay, Nicholas, very good. Normal line. Okay, a line which is perpendicular. Remember, normal line is a line perpendicular to the boundary. So this is the boundary. Okay, the boundary between the deep region and shallow region. So normal line is a line perpendicular to the boundary of the two medium. Okay, so you can see that is a normal line. And this is the angle of incidence. If you can see here, this is the incident wave propagating in the deep region. So this is our angle of incidence, I. Okay, angle of incidence. And then this is our refracted wave. Ini kita punya refracted wave and this is our angle of refraction. Okay, angle. Yeah, 90 degree Yifong. Perpendicular mean 90 degree. Normal line is a line which is 90 degree or perpendicular to the boundary of the two medium. Okay, so this is I and this is R. So you can see that as the direction changes, now I will be never equal to R. Okay, remember in refraction, I could be never equal to R. Okay, dia berlawanan, opposed to what happened in reflection. In reflection, I always equal to R. Okay, but for refraction, I will never be equal to R. Okay, because later on the refracted wave either move towards or away from normal. So that's why I and R will be always different. Okay, next. Okay, so let's check on the next slide. So this one, how to know, students, duit saya tiada ni apa? How to know either the refracted wave will be refracted towards or away from normal. Okay, now I am using this formula. Duit saya tiada, DST. Okay, D itu stand for deep region. Okay, S itu shallow region. And T stand for towards. Okay, which mean when the water wave travel from deep region to shallow region, it will be refracted towards normal. Okay, so as you can see here, traveling from deep region, entering shallow region, it will be refracted towards normal, where you can see that I is greater than R. Cannot see. I use a different ink. Okay, where I is greater than R. Okay, when the wave move from deep to shallow region, so you can see it will refract towards normal, where I greater than R. Or you can say R less than I. Okay, ini high density. For water wave, GIU, the density is the same for water wave because it is the same type of liquid. Okay, the difference is in depth, different depth. Okay, so for water wave, move from deep to shallow region, so it will move towards normal. Okay. Water wave density dia sama sebab dia same type of water. The difference is in depth. So different depth will causes different velocity. So different velocity definitely will change the direction of motion. Okay. Okay, then what's next? Okay, remember deep to shallow towards. Duit saya tiada. Okay, you can use this acronym. Okay, then what's happened next? In figure 5.42. Okay, 5.42 you can see in the simulation up here. Now the water traveling from shallow to deep region. Okay, you can see from shallow to deep region. So from shallow region, this is the direction of propagation. Okay, and once it entered the deep region, you can see that the direction changes. Okay, it propagates upwards. Okay, it propagates upward. This is the boundary between the shallow and deep region according to the shape of this perspex placed here. Yeah, for depth. For water wave, it is due to depth. Okay. Okay, then next. So how to draw? How to draw? Where in which direction either propagate away from normal or towards normal. So again, the blue line shows to us the normal. Okay, what is a normal? A line which is 90 degree or perpendicular to the boundary of the two medium. Our medium here is shallow region and deep region. So what is the formula I'm using here? Saya dapat ampau. Tadi saya tiada duit. Sekarang saya dapat ampau. Okay. S ini stand for shallow region. Okay, D ini deep region. A itu away. So when the water wave move from shallow to deep region, it will be refract away from normal. Okay, senang saja. Duit saya tiada, saya dapat ampau. Okay, so how? Here. So this is our, if you draw, this is our angle of incidence, I. Okay, and this is our angle of refraction. So now you can see here, I less than R. Okay, or you can write the other way around, R greater than I. Okay, so from shallow to deep region, water wave refract away from normal. Okay, so dia jauh daripada normal, so dia travel upwards. And this is the refracted wave. How we draw the refracted wave? We must draw a wave 90 degree to the refracted wave. Okay, so I hope you're clear with this too. From shallow to deep, what happened? And from deep to shallow, what happened to the water? In which direction it refracted to, either away or towards normal. Okay, okay then. So this is what the characteristic of wave. How do they change from deep to shallow or from shallow to deep region? Okay, first and foremost, angle of incidence, angle of refraction, as we see from the two activity on experiment 5.4. So from deep to shallow, so deep to shallow is towards. So towards mean R must be smaller or less than R. Okay, while from shallow to region means away. So away R must be shallow to deep. Okay, so ini towards, so dia mesti kecil. Deep to shallow dia away, sorry. Okay, deep to shallow away, so R must be greater. And then shallow to deep is towards normal, so R must be less than I. Okay, and what happened to the wavelength? What can you say about the wavelength? From deep to shallow, is the wavelength unchanged or increases or decreases? From the drawing I showed to you earlier. Okay, we go back to the drawing and you check for the wavelength. Okay, here, figure 5.41. Okay, check on the wavelength. Can you see the wavelength there? From the deep region, you can see that the wavelength is greater. Okay, the wavelength is greater. And entering a shallow region, you can see that the wavelength decreases. Okay, same goes here. Deep region, the wavelength is bigger or longer. And then here, the wavelength shorter or decreases. Okay. While for the second, from shallow to deep, you can see that here shallow, the wavelength is smaller, okay, or shorter. And entering a deep region, you can see that the wavelength increases or longer. As shown here, sama juga di bawah ini. Here, shallow region, the wavelength is shorter. At the deep region, you can see that the wavelength is longer. Okay. So for this, okay, we write the second characteristic on the wavelength. Okay, this one decreases. From deep to shallow, the wavelength becomes shorter, decrease. Okay, while from shallow to deep, what happened to the wavelength? It is become longer or increase. Okay, what can you say about the frequency? Any changes on the frequency, students? What do you say?
No.
No changes. Why no changes? Why no changes? Why the frequency does not change?
Same depth.
Same? Why the frequency does not change? Because they are coming from same sources of wave, same vibrator producing. The wave are producing from the same vibrator. So they are coming from the same sources of wave. So that's why the frequency remain or unchanged. Ingat either for reflection or refraction, the frequency does not change because the wave is coming from same sources. Sumber yang sama. Okay. How about the wave speed? Wave speed. From deep to shallow, what happened to the wave speed? Increase or decrease?
Increase.
From deep to shallow, wave speed. It will decrease. Okay. Actually, wave speed related to the wavelength. Okay, wave speed directly proportional to wavelength. If you remember this formula, you ingat tak formula ini? Formula for wave speed. I'm using a different point. Okay, so if you remember, this is the formula for wave speed. V equal F lambda. Okay, V equal F lambda. Student, what is the relationship between V and lambda here? What is the relationship between V and lambda here? They are in the same line, right? Mean V increases, lambda also increases. So they are directly proportional. So if the wavelength decreases, so do the speed decreases. Okay. While from shallow to deep, so dia akan increase. From shallow to deep region, the speed increases. It means that a water wave travel at higher speed in a deep region. Okay, and water wave travel at a lower speed in a shallow region. Okay, next, direction of propagation. Okay, what to say about the direction of propagation? So in which direction? Towards or normal? Towards or away from normal? Deep to shallow. Deep to shallow. Deep to shallow tadi. Deep to shallow. Deep shallow region. DST. Okay, duit saya tiada. So towards. Okay, this one shallow to deep. Shallow, deep, away. Saya dapat angpau. Okay, so you can say what happened to the direction of propagation. Refracted towards normal. Okay, deep to shallow, refracted towards normal. From shallow to deep, refracted away from normal. Okay, shallow, deep, refracted away from normal. Okay, saya rasa di atas ni macam terbalik. Okay, do you think angle of incident, angle of refraction? Terbalik kan? This one, above. What do you think? This one, mana yang lebih besar patutnya? Deep to shallow. Towards. Kalau towards, betul lah. I besar daripada R. R kecil. Okay. This one apa? Only apply for that. Bukan depth. Depth. D-E-P-T-H. Okay. Jayu wrong spelling that. Ikhlas. Okay. Ini. So towards, betul lah. Ini R kecil. Okay. Away mean R greater than I. Okay, are you doing good so far, students? Can you follow me? Characteristic of wave, especially water wave, when travel or propagate from deep to shallow, what happen? And also traveling from shallow to deep region. Okay, tell me, are you doing good so far? Sinwei, can you follow me?
Yes.
Boleh faham cikgu? Can?
Teacher,
Okay, yes.
Tadi itu formula.
Which one? B.
Determine the V and the lambda is
V equal F lambda. Yes.
How we know that it is directly proportional?
Directly proportional because they're in the same line. V and ini in the same line. Okay? Dia garis yang sama.
So means that the F is constant.
F is constant here, frequency unchanged. Okay, when F is constant, so what happened to V as lambda increases? So lambda increases, V also increases. Okay?
If the lambda is constant,
If the lambda is constant, then V is
then
constant. No? Okay?
lambda
Okay.
constant, V also constant.
Lambda dia changes with, V changes with lambda. Okay, V changes with lambda. So normally for refraction, F itu always constant. Dia mesti constant. So bila dia constant, if lambda increase, V increase. So if lambda decrease, V also decrease. Okay?
Okay, thank you.
Okay, very good. Okay, they are equal. Bukan dia equal, bukan maksudnya V 30, lambda pun 30. Maksudnya bila lambda ini dia tinggi, V pun akan tinggi. Okay, let's say here, let's say now F is, let's say we give a number, frequency is 1 Hertz. Okay, you letaklah berapa number. If lambda, okay, I give you this example, we draw. Okay, let's say we draw, this is the depth of water. Ini the seabed. Let's say lah ini air macam ini. Okay, let's say kita ada non-uniform seabed. Cikgu padam dulu. Okay, so let's say ini kita punya pantai. And this is the water level. Okay, so this is a deep region. Okay, ini shallow region. So the water traveling here, traveling at high speed. Okay, traveling at, so if you draw the wavelength here approach shows like this. Dia macam ni. Then entering the shore, the wavelength becomes shorter. Okay, here speed is high. Let's say speed here, let's say we give a value. Speed here is 30 meter per second. Okay, where the lambda is, let's say 5 meter. Okay, example. So here the speed, let's say become 20 meter per second. So the lambda must be less than 5 meter. Katalah dia 3 meter. Okay, so here we can see that when velocity decrease from 30 to 20 meter per second, the wavelength also decreases from 5 decrease to 3 meter. Are you clear, Yifong? Bukan maksudnya the value for lambda and V itu sama. Lambda 30, V pun 30. No. Okay, mean lambda decreases, V decreases. Lambda increases, V also decreases. Okay. Okay, next. Let's check on. Okay, that is the first learning standard. To know the characteristic of wave, water wave, when traveling from deep to shallow and shallow to deep region. Okay, very good. Okay. Then we move to standard 2. Learning standard 2, you must know how to draw diagram to show refraction of wave of 2 different depths. So when we are talking about 2 different depths, so we must refer to water wave. Okay, the two different medium is two different depth, shallow and deep region. Okay, so this is the step. So if you look at the module I prepared, you have to complete the ray diagram refracted from either shallow to deep or deep to shallow. So this is the step 1, 2, 3, 4. So what is the first step? First step, you are given this diagram. This is the initial diagram you are given with. So first and foremost, what you need to do, you have to draw an arrow line AB ini. Line AB, number 1 ini, line AB. You can see line AB there, perpendicular to the incident wavefront. So this is our incident wavefront, the blue line. Ini kita punya incident wavefront. Okay. So to represent direction of propagation. So AP ini direction of propagation of our incident wave. Okay. Second, you have to draw the normal. Draw the normal which is perpendicular to the boundary of the deep region and shallow region as shown in B. So second step, we draw the normal line. Normally we draw the normal line with the dashed line. Okay. So kita boleh bezakan mana satu normal, mana satu boundary. Okay. Tapi tak salah if you draw it with a bold line, no problem. As long it is perpendicular. But to differentiate with the boundary, normally we draw the normal with dotted or dashed line. Okay, then what is the third step? Third step ini number 3. You draw line BC. What is line BC? Line BC which is closer to the normal, okay, than AB. This line BC represent the direction of propagation of the refracted wave, okay. So the blue line here is the wavefront of our refracted wave. So ini dia punya direction of propagation of the refracted wave. Why towards? Sebab dia deep to shallow. So ikut formula tadi. Deep, above here deep. Okay, below here is shallow. So the wave propagate from deep to shallow region. So deep shallow is towards. Duit saya tiada. Deep shallow refracted towards normal. So you can see that I greater than R. Okay, I greater than R. Okay, got it students? And the fourth step, what is the fourth step? Ada ke fourth step? Fourth step inilah kita draw the incident, the wavefront for the refracted wave. So draw 3 line. You lukis at least 3. Kalau dalam exam, berapa line nak lukis? At least 3. 3 incident wavefront and 3 refracted wavefront. Okay, draw 3 lines perpendicular to BC to represent the refracted wavefront. The line must be closer to one and another. Why? Kenapa kita mesti draw closer? This is to show that the wavelength decreases. Okay, wavelength decreases from deep to shallow region. Okay, so ini you boleh tengok. In the deep region, wavelength longer. Means wave travelling at a higher velocity. Entering a shallow region, the speed decreases. So they move towards normal and the wavelength also decreases. So I hope you're clear with that. The 4th step, how to draw refracted wave. Okay, then this one you can practice. Okay, I give you a few minutes to practice this. If you cannot print out, you can draw this diagram in your exercise book. Okay, ada 2 gambar saja. Okay, I give you how long do you think you need to complete this diagram? So you have 2 diagram. The first diagram, the water wave traveling from deep region entering shallow region. And this is the way we place the perspex place. Again, student, what is the purpose of the perspex place? To create shallow region. Okay. And this one also we place the perspex plate here to create a shallow region. So the second diagram, the water travel from shallow entering a deep region. So you have to draw the diagram of reflection refraction according to the 4-step guided in the previous slide. So to help you, I use this formula. Nanti keluar awal sangat. This one you can use this formula DST, deep shallow wave propagate towards normal. Okay, and this one you can use the other one. Saya dapat ampau SDA, shallow deep away. Okay, okay, try to do it. I give you a few minutes to complete your drawing. Later you can compare with mine. Okay, cuba lukis Sinway and the rest of you. Sinway is the only one joining my studio today. So the rest of you, please draw your diagram. I give you 3 minutes enough? Cukup tak 3 minit?
Teacher,
Yeah, Sinway.
how the speed, how the density affect the speed?
Here density no effect on speed because same type of water. Okay, same type of water. So don't see density not changes here. Okay, for water wave density no changes. The changes is in depth. Changes in depth, changes the velocity, changes the wavelength. Okay. Later density, you will see the effect of density when we are dealing with sound wave and also light wave. Am I answering your question? Okay, you can proceed with your drawing first. Okay, everyone, boys and girls, I hope you are started with your drawing now. How is the pattern of the refraction of plane water wave when moving or propagating from deep to shallow region as shown in diagram 1? And second, when propagating from shallow to deep region as shown in diagram 2. If you are done, you please type down there so I can start discussing the answer. Okay. So I hope you will all cooperate with me. If you are done, then type there done. So we can start discussing the correct diagram for both situation.
Teacher,
Yeah.
I mean that in the previous slide,
Uh-huh.
the shallow part, the speed will be lower, right?
Yes. Yeah. Shallow part speed lower.
Why the speed will be lower?
Kenapa? Actually dia relate to energy, amplitude. Okay. When the water travel in the deep region, they travel with a higher energy, higher amplitude, and the amplitude decreasing. Okay, the energy decreasing as they are approaching the beach or the shore. So this will change the speed and change the wavelength. Okay, you tengok kan, ombak besar, energy dia sangat tinggi. Or you tengok air yang sangat tenang, energy dia very low. Okay.
Okay. Thank
Okay.
you, teacher.
Are you done with your drawing? Still doing? Okay, those who are done with the drawing, you can type there done. So we can start discussing the correct diagram you're supposed to figure out according to these two situations. Again, for those who cannot print out, you can draw this diagram in your module. This is the first situation. Water wave travel from deep to shallow region. Okay, and this is the boundary between the deep region and shallow region. Okay, and for the second case, the water is travel from shallow to deep region. And this is the boundary between the shallow and deep region. Okay, Nicholas, done. Very good. What about the rest? Are you still doing? Okay. Okay, just use this formula, deep to shallow towards normal. Shallow to deep, away from normal. Then you won't get lost. Okay, anyhow. Okay, So I think I show you because we have about 10 minutes left. So I show you how's the pattern, students. Okay, first, okay, this is, so they give you the first step. The first step, they have draw the incident wave for you. Ini the wave front of the incident wave. So second step, we draw the direction of propagation shown by this red arrow. So this is the direction of propagation of the incident wave. And then third step, we draw the normal line. Okay, ini step yang kedua, we draw the normal line, second step. Then third step, we draw the refracted wave. So towards normal. So towards normal dia, towards normal, dekat dengan normal. Okay, so when you draw the refracted angle, you must make sure incident angle and refracted angle must be at the opposite side. Ini you punya normal kan. So incident angle di sini, sebelah kiri. So your refracted ray mesti ada di opposite side. Dia mesti ada di sini. Okay, opposite side. Ini dia on the left of the normal, R ini on the right side of the normal line and towards normal. So we draw in this direction. So what is the fourth step? So fourth step, you draw the refracted wave. Okay, refracted wave 90 degree to the direction of propagation. And we draw it closer to one and another because in shallow region, the wavelength is shorter. Okay, so you have to draw the distance closer to one and another compared to the distance in the deep region, showing that the wave refracted towards normal where the wavelength decreases. Okay, while for the second diagram, from shallow to deep, supposed to be refract away from normal. So first step, okay, so first step, we draw our direction of propagation of the incident wave. Second, we draw the normal, a line 90 degree to the boundary of both medium. Okay, and then we draw the refracted wave. So refracted dia mesti away. You jangan lukis di sebelah sini you jangan lukis di sebelah sini pula. Kalau you lukis di sebelah sini, you tengok tak dia dua-dua sebelah yang sama. Dua-dua di sebelah yang sama, which is wrong. Dia dua-dua on the left side. So you must look at that at the opposite side with I. So this is the correct place to draw R. And it is away from normal. And the fourth step. Okay, so what is the fourth step? You draw the refracted wave. Okay, so we draw the distance further. Why further? Because in the deep region, the wavelength increases. So what we have here, from shallow to deep, the wave refracted away from normal with increasing in wavelength. Okay, who got it right for both diagrams? Siapa lukis kedua-dua betul? Angkat tangan. Tulis di sana, saya, ni. Okay, anyone draw correctly for both diagram? So just follow the fourth step and then follow this guidance. Deep to shallow towards. Shallow to deep away. Okay. Okay, and then the third learning standard. Okay, the third learning standard, students. Okay, you have to explain natural phenomena of reflection in our daily life. Kita tengoklah di sini. Okay, there's a question here. Why sound cannot be heard over a long distance on a hot day? If you notice, when you watch television during a day compared to night, the television sound clearly, okay, at night. Suara TV dengar dengan lebih jelas pada waktu malam, even though the volume is the same. Okay, why on day you cannot hear a sound clearly? So why sound cannot be heard over longer distance on a hot day? So this is what happened. Okay, on a hot day, the air layer near the surface of the ground is warmer. Ini, bawah ini dia lebih panas. Okay, permukaan jalan lebih panas. So the air layer near the ground is warmer compared to the air above. Walaupun atas ni ada matahari, jangan you nampak sana ada sunlight, you kata atas ini lebih panas. No, the air near the ground is warmer and it getting cooler once the altitude increases. Okay, kawasan tinggi, cuaca dia sejuk, lebih tinggi from the ground. Okay. Second, sound wave travel faster in hot air. Okay. Sound wave travel faster in hot air. Then sound travel from warm. So sound dia dari bawah. You play here. So the sound wave travel from hot air to cold air. So the speed of sound decreases. Okay. Speed of sound decreases. Can you tell me which one is denser? Warm air or cool air? Students. Which air is denser? Warm air or cool air is denser? Logically, denser dia akan duduk di atas ke bawah? Kalau denser material will stay above or below? If you look from logic, denser material will be below. So warm air itu denser. So denser mean the air molecule is closer to one and another. Okay, the air molecule here closer to one and another, so give a higher density of warm air. So in cool air, less dense. Okay, cool air ini less dense. So water molecule, dia punya air molecule is less compare. Less. Air molecule dia less compared to warm air. So sound wave to travel, they require medium. So for sound wave to travel, they require a particle. So here more a particle to carry the sound. That's why they travel faster in warm air. Okay. In a cool air, less a particle to carry the sound. So that's why sound travel slowly in a cooler air. So I hope you understand with that. So that's why speed of sound decreases from warm air entering cold air. So what happened? The sound wave will be refract away from the ground. So dia naik atas. So naik atas, it doesn't reach our ear. So that's why sound wave cannot hear over a longer distance on a hot wave, on a hot day. Sorry. Okay. And at night, the opposite thing happen. Okay. At night, the air below the ground is cooler compared to the air above the ground, which is warmer. Okay. So what happened? At night, the ground is cooler. A layer near the ground is colder. Okay. So by this, sound wave travel. Okay. Sound wave travels slower in cold air, and it travels from cold into hot air. Okay. It travel, speed of sound increase. Then sound refracted towards the ground. Okay, they are refracted towards the ground. Okay, so you need towards the ground. Ini day and night. So at night we can see, we can hear sound more clearer compared to a day. Okay, and this one, application of water wave. Okay, water wave. You can see when the wave approaching the beach, you can see that they will follow the shape of the shoreline. And why is that occur? If you see from top or if you see from distant view, kalau you lihat daripada jauh students, the water at the ocean, at the middle of the ocean or away from the shoreline, the wavefront is almost straight. Okay, dia punya wavefront straight or plane and parallel because water wave travel at a uniform speed. But as approaching the beach, bila dia menghampiri pantai where the depth decreases, now you can see that there will be changes in the shape according to the shape of the shoreline. It is different on the cape and at the bay. You tengok sini ada dua region, cape and bay. So what happened? The cape is shallower. Cape ini, the cape. While the bay is deeper. So what happened here at the cape? The speed of wave decreases, causing the wavelength to be shorter, shown by the blue wavelength here. Okay. While at the bay, what happened? The wavefront, the bay moving at the higher speed compared to the cape. Okay, wavelength dia longer. So at cape here, wavelength longer. Bay here, wavelength longer compared to the cape, wavelength shorter. And the wavefront curve follow the shape of the shoreline. Okay, this one, the wave spread. Okay, so it formed a longer wavelength, follow the shape. And here what happened, the wave converge to a point. Ini dia diverge. Okay, converge to a point. Kalau you tengok shape of the cape, itu dia shape dia convex. So the wave converge here, producing shorter wavelength. Okay, while at the bay is appear to be as a concave shape. So what happened? The wave diverge and producing longer wavelength. Okay, here. And then what's next? Okay, ini. So why the water at the cape has a high wave? Kalau you tengok in these two region, if you want to do an activity, which place is safer, at the cape or at the bay? Kalau you nak mandi di mana? At the cape or at the bay? Normally we choose to swim at the bay because the water there is calmer compared to the water at the cape. What happened at the cape? More energy convert at the cape area. So the wave has a high amplitude. So ini air dia lebih deras. So bahaya kalau you mandi dekat sana. Okay. While at the bay, why the water is calmer? Because of the shape is concave. So the energy spread or diverge into wider area. So this causes the amplitude to be lower. Low amplitude means low energy. So the wave is calmer and more safer to swim there. Okay, itu standard 3. So I think I stop here for now. Ini kita nanti sambung. Solving problem on refraction of water wave. Before that, I want you to open your workbook and try to do these few exercises. Okay, check first before we dismiss. You go to page 100 and 138, if I'm not mistaken, 138. You check on the pages first, student. 138, okay, 137. It started with 137. Okay, please complete activity A. There are 5 questions there. And then I want you to try to do Uji Kendiri 5.4.1. And also activity B in page 138 until page 140. Okay, boleh tak cuba jawab? Okay, so I repeat from page 137 until page 140. 140, you skip Uji Kendiri 5.4.2 first. Okay, so any question you may ask in the Telegram group, ada apa tak faham, ada apa boleh tanya dekat sana. So I think that's all for today. We have covered the 3rd learning standard, the first 3 learning standard. First, how to justify the characteristic of wave after experience refraction. And then second, how to draw the patterns of the refracted wave. And then third, example of situation related to refraction of wave. So we have discussed 2 types of refraction, sound wave and water wave. Okay, so I hope you are clear with this lesson. If there are any difficulties, you may watch this video again to get the full content. And for the exercises, please try to do them. So we will discuss more example of problem solving related to refraction of wave in the following session. Okay, anything else you would like to say before we dismiss? Ada apa nak tanya? Okay, anything you would like to ask before we say bye-bye? Tak ada. Sinway, any question? Okay, if you don't have any further question, kalau ada you tanya nanti dalam Telegram group. Okay, I will reply to you there. So thank you very much for your presence. Don't forget to fill up the attendance form. Okay, students, please fill up the attendance form. Later, I will show it again here, the attendance form. Okay, you don't have to upload any works. Just complete your exercises at home. So I hope everyone will do the exercises. Please give a try. So it will test either you can follow this lesson well or not. Okay, thank you all. Thank you everyone. So please take a good care of yourself. Take a good care of your health. Talking about health, there are three types of health you must take a good care. Physical health, and then your apa lagi? Spiritual health, and then your mental health. Tiga ini tolong jaga dengan betul and manage your time wisely so you won't get stressed up. Any problem you can always discuss with the teacher. Okay? So I hope that's all for today. Again, thank you very much. See you again soon. Bye-bye, everyone. Okay? You may leave this lesson now and get ready for the next one.